Is my screen visible?
No, still Karthik's visible. Yeah. Hi Priyanka, hi guys. Like this is Veeresh, and like my hobbies are I'm a bike rider and playing cricket.
Okay.
What do you like? Can you introduce yourself?
Yeah, so I'm Priyanka, and my hobbies are singing music and playing musical instruments. Yeah.
Okay.
That's
Like today's into discussion is about designing a web crawler. Like web crawler means we need to index the URLs and we need to crawl them. We need to store the download the URLs and collect the data and store it for our use case. And it might be something like one time or repeatedly in a loop we need to crawl. So uh, can you list the functional requirements?
a functional requirements of.
Yeah, like, I will tell like what all required.
Okay.
Yeah. For me, required things are like we need to have a like a URLs list. Like means we need to have a URLs and we need to prioritize those URLs based on priority order. Um, like priority order might be like new data, like new URLs or most viewed sites, something like that. Yeah, and we need to avoid duplicates.
Okay.
And extract those links. And we need to like every website will be having the separate text file called robot.txt, so we need to respect that. Like yeah, we need to respect robots.txt. And for scalability purpose, currently like we can have like 1 lakh URLs per day or per hour. Like this is what I wanted our system to handle.
1 lakh. What is it?
1 lakh URL per day.
Per day. Okay.
Yeah. And we need to store the crawl data.
We need to
store the data which we crawled.
Okay.
And non-functional requirements like if you want to scale up from 1 lakh to 10 lakh, so it should be scalable. Like we can scale it to any extent we want.
Okay.
Yeah. And it should have low latency and high scalable. Yeah. Means it should have scalability. That's it. Like highly scalable and low. Yeah, and low latency.
Okay.
And high throughput. Yeah. These are the requirements. Can we start with like high level design and then get deeper into it?
Yeah. Sure. So for
do you have any like before starting? Do you have any doubts in the requirements?
no, this is fine. So per day, that web scroller should scroll up to 1 lakh URLs,
Yeah,
right?
that should handle, yeah, with low latency.
Okay. Yeah. So firstly, let's start with the components of what all the web scroller has. So web crawler, I mean, sorry. Yeah, what all the web crawler has. So at first we have here, if you see. Hmm. So at first we have seed URLs. So what we do, seed URLs are nothing but where we give the list of URLs for the web crawler to start crawling into multiple websites to get its information and store it in the storage. So first, what it will we will give the seed URLs from the uh, developer or whoever is creates web crawler. So seed URLs are the list of URLs. For example, like if you see, it can be either it can be a it can be a college URL, or it can be a news URL, or it can be
Okay. Yeah,
any
got it.
commercial URL. Yeah. So those URL lists, like for example, google.com, or it can be Wikipedia. So the list of URLs will be given here. So the next we will be giving that, we will be feeding that data to this frontliner. So frontier, I mean. So what is frontier? Frontier is basically takes all the seed URLs, and it starts to schedule with those URLs, and where that URL like when and what time, the based on the priorities, frontier will crawl into the multiple websites. So we'll be using this component. So frontier role will be like the queue of all the URLs, and if there is any hyperlinks, all the things will be listed inside the frontier, and it will be scheduled based on the priority. So we will be using frontier and scheduler.
Is it like a batch? Like, will it process in batch, or one component will be having only one URL? Like in Frontier, there will be multiple queues. Like in queues, multiple objects will be there. So each object is capable of scheduling for one URL, or in a type of batch URLs.
Batch URLs. It can be capable of batch URLs, but yeah, we can also configure multiple frontiers. If there are large list of URLs, we can use the same single URL as well. If there are multiple hyperlinks into the same URL.
Okay, but how are you make sure that there will be no duplicate? Like in seed errors, there might be a duplicates list. So how are you make sure that it won't like multiple entries not created in the queue?
So the deduplication will be taken care by another component, which is
Okay.
yeah, which is the
Okay.
bloom filter, we say that. So I'll come to the later part. So this is only the role is to like schedule and have the queue of URL queue where one after the other which URLs has to be scrolled. So then we have the next component, um, the fetcher. So what exactly fetcher does? Fetcher will send the HTTP get request, HTTP get request to all the websites which are present for the frontier to crawl into the websites. So it will give the HTTPS get request. Yeah. Now, in case for the fetcher to send HTTPS GET request, it has to go to the DNS, like public DNS, and again check for the, because here we are giving google.com, you have to fetch the website content, but in the fetcher understands like it has to be converted, the DNS has to be converted from FQDN to IP. Hence we for delaying, like if it has to reach to the public DNS or anywhere, there will be a delay. So for reducing some of the latency, what we can do, we can create a DNS resolver. So the resolver caching, so that what happens here is DNS resolver caching resolves the IP address and stores some of the FQDN and IP address, mapped IP addresses for these FQDNs.
Okay.
So it does the caching part so that the DNS resolution latency will be reduced. Then what happens? Then there
But
is
like
another.
you said you will not be processing duplicates. Then what's the use of DNS caching? Because for per URL, IP address will be different. And if you are catching this, what will be the use case? Anyway, catching doesn't it, and you need to again call up DNS and you need to resolve IPs, right?
Yeah, like if in case some of the popular URLs, it has to continuously recrawl every day. So if it has to recrawl every day on daily basis, like news channel, the web page, the what you say, like for example, New York Daily News is there. So that website FQDN will never change. So that IP will always
Okay.
be mapped to same. So if it has to recrawl every day for the same FQDN, then we can use the same DNS resolver caching so that it is already stored in the cache. It will not go to public DNS or anywhere else to do the DNS resolution. So that way, it will be useful.
Okay.
Then we have another component called HTML parser.
Okay, but if DNS resolver cache is miss, then how are you getting that IP address? That component is missing, right?
Can you come again?
Like you designed a cache for DNS, and if that cache is miss, it doesn't it, then how are you getting that IP DNS? How are you resolving that DNS?
Uh, so if that IP misses, either it can resolve to the public DNS itself, because always the public DNS will have the entries. So if
Yeah,
something
can you
happens to
add
the
this
DNS,
component?
okay, if yeah, I'll just add it. So if something happens, or so if something happens for the DNS resolver caching, that cache is not available or something, it can always go to the resolving from public DNS, or where the entries are always present globally for all DNS. Yeah.
Okay.
Then we have the next component, which is HTML parser. So what HTML parser does is it once the frontier has the list of URLs to be crawled, then fetcher sends the HTTP GET request. Then the HTTP GET request is done. The HTML parser will like this component will go to the website and get the HTML content, its images, metadata, all the related content, all the required content will be taken care by HTML parser. And it also, if there is any hyperlink, for example, Wikipedia, if you take an example, there are many multiple. So every time it will take the multiple hyperlinks and also send the same request to Frontier. So it will also require extract the URLs of many hyperlinks present in the website.
Okay. I have one doubt. Like, how are you handling static website and dynamic website? Like, if the content is updated in dynamically, then how your HTML parser is handling that part?
Can you come again?
Like I
If
mentioned, if the website is dynamically updated, and how are you maintaining the HTML parser to parse those sites?
okay. So if it is, I am not sure about this answer. if it is getting passed, like if the site is dynamic or on daily basis, maybe the most required solution will be recrawling and scheduling the recrawling for every frequent hours of in a day, so that the dynamic content is always being updated in the storage.
Okay.
But
Can
I'm
you?
not sure about that answer.
Yeah.
Yeah.
I can explain that later.
Okay.
Okay.
So then, for like if you see here, there will be multiple duplication of the URLs. There will be like multiple there will be multiple URLs, infinite URLs in the same content or same web page. So for avoiding that deduplication, we can use Bloom filters for checking if there is any if there is any content being duplicated under the multiple URLs, so that it doesn't have to do the recrawling again and again for the same content of the site.
Okay.
And that is being done with by that duplication content is checked with the entire web content is taken with that SHA 256. So if the content is same in that, then it will not go for the recrawler. So that is taken care by the component Bloom filters.
Okay.
Yeah. Yeah. Then once all these are checked, what happens is once all these are checked and once there is no duplicate URLs and there are original URLs which has to be like once this is done, what happens next? It has to whatever metadata is stored in the HTML parser and all that. It will only the original content will be stored in the form of in a storage. So that storage we can differentiate it into two types. One is for storing the images or the content of the HTML,
Okay.
as it is a vast HTML storage content for images or that exact web content is vast. So we will be using S3 bucket in Amazon, or we can, if you want to go with Azure, you can go with blob storage, or you can also use higher level of like storage account and or file shares, everything is there to store that huge amount of data. So so that can be used for storing web content. If not, we can also use another thing for storing the metadata. Like metadata means what crawl details is done, when the what is the crawl status, is it completed or not, or to get all the details related to crawl or the metadata of that application. What is the website of that? What is the website name? So all those details has to be taken. Has to be in the structured format. So for that, we'll not use S3 or storage account in Azure. So we can go with Cassandra for structured storage.
Okay.
Yeah.
But but in the functional requirement, I listed that we need to respect robot.txt. So I didn't saw anywhere you mentioned or you analyze that. Is it allowed to download that site or something kind of a thing? Can we add that component also?
Yeah.
Yeah.
So basically, what I'll explain what is robot.txt. Robot.txt is basically like if we browse for wikipedia.com, then if we put /robots.txt, it will give the page like what all has to be crawled, only that has to be crawled. What is not required or private data, that has to be always respected. And also there is something called politeness as well, which where you have to give request like per for per 5 seconds, only one request has to go so that you don't overload the website as well. So for mm, that will be taken care by fetch worker itself. If you see here, we have
Okay.
robot.
Okay.
Yeah, just
Yeah. Okay. Now, can we come to non-functional requirement? Like, if you want to scale up, see, currently you designed for around 1 lakh. So, if I want to scale it up now to 1 million per day. So, how can we scale up without making much architectural changes?
scaling up. What we can do. We can basically frontier or scheduler will only have the list of URLs of what all has to be given. The more work will be taken care by fetcher
Okay.
or headset. So for fetcher, what we can do, we can enable auto scaling. So whenever the request from outgoing or incoming request is high, we can enable auto scaling capability like VM scale sets we can use, or yeah. So in Azure, we have that option called VM scale set. So similarly, equivalently, we have in Amazon as well. So we can use those VMs so that if there is any additional increment of inbound and outbound traffic is more, then what will happen? It will automatically scale up for fetcher. And HTML parser also, we can scale it up. But for example,
Oh.
if fetcher is fetching more requests fast, and I'll just put here for VM scale sets.
And like you said, like you'll do parallel processing. Like will for in parallel processing, deduplication filters, everything would be part like for per worker separate components will be there, or it is a shared component, duplication filters or yes, HTML parser, everything.
Uh,
I said is HTML parser and duplication filter is shared component or per worker separate would be there.
Guys, last 7 minutes.
Yeah.
okay. So it will be a separate component itself. Yeah.
Okay. Why not shared?
To the last component. So once the web content is stored in S3 bucket and metadata is stored in Cassandra, so the last component will be indexing. This last part will be indexing. So what indexing does is, when the website is stored for efficient search, like Google and all has to have that efficient search and accurate results. So indexing will be taken care, where the web content based on the keywords or based on keywords present inside the website, that will be mapped with the IDs, document
Okay.
IDs. So that through that ID only we will be able to fetch that exact web pages. So
Okay.
that is why we have index pipeline. Now for fresh, now this one crawl is done. Now again the fresh crawl has to be done. Then once the deduplication, all this content is done, the scheduler will have the scheduling data again. For recrawling, for example, we can do the we have this feature in scheduler where we can do the schedule the recrawl for the particular websites, like for news channel where every day the data keeps changing. So for that we can schedule it for every day or like that. Then for college
No,
or
no. Dynamic content means once you load that website, in that website content changes. It's not daily
yeah,
changes.
yeah, that I'm not sure. Oh,
Okay.
yeah.
Yeah. And why
But
can't
more
we
efficient.
share? Okay, like one question I have: why can't we use a duplication filter or HTML parser as a shared component? or at least duplication bloom filter, deduplication filter.
We can use, I guess, I'm not exactly sure
Okay,
about
okay.
that as well.
I wanted to ask what are the pros and cons of both use cases. Okay, it's fine. And how are we maintaining low latency? Like, what will be the time complexity of like even HTML parser or the bloom filter?
So even more, if we can up one way is for DNS resolver caching. Another way, we can reduce the latency by using Kafka in this component. So what happens here is like. What happens here is when the fetcher is sending more get request to the HTML parsers, but HTML parser is not able to download the content of the website. So then what happens? What happens here is there will be overhead of operation. So we can use Kafka for distributed queue system. So that way it can also reduce the latency.
Can you
From
explain more like
HTML.
how Kafka using Kafka as a scheduler reduces latency? Because anyway, even if you're using Kafka as a thing, the HTML parser, everything need to go. So here we need to optimize parser and duplication filters complexities, right?
Correct, but
Yeah, it's fine. Like, can we continue?
yeah, we can continue. Just thinking.
Yeah. That's all I had. Like, do you have any questions for me?
No.
Thank you. Yeah. What do you, Karthik?